Welcome back to Demystifying 5G, a video series brought to you by Rohde & Schwarz. Today I want to talk to you about UFMC demodulation. UFMC, Universal Filter Multicarrier, one of the 5G waveform candidates that's currently being discussed in the industry to overcome one of the limitations of LTE, for instance, spectrum agility. So Rohde & Schwarz implemented those waveforms. There's a few of them beside UFMC, FBMC, GFDM, filtered OFDM, and so on, into our signal generation and analysis tools. And let's take a look how we can analyze a UFMC signal. So first of all, I brought you setup here, which is the SMW and FSW, the signal generator and analyzer. So our signal generator is currently generating a UFMC signal, and the FSW will be used to analyze this signal. With the FSW, I'm using a software tool. This tool is called OFDM Vector Signal Analysis Software, K196, which has the capabilities of analyzing a UFMC signal. Let's take a look. So what you basically see here is the default configuration on our signal generator. I picked the frequency 4.2 gigahertz and the power level. Let's take a look at the OFDM software here, the K96. As you can see, it's a software tool provided to you by Rohde & Schwarz. It is interfacing to the FSW signal and spectrum analyzer that you saw earlier via Ethernet, and it's capturing the IQ data and post-process this with the software. Now, what we have to do is basically tell the software that we want to analyze a UFMC signal. If you install the software, you basically get into the OFDM Vector Signal Analysis Software directory, a configuration folder, and within that configuration folder you see here a couple of configuration files, for instance, as an example for UFMC. I just simply drag and drop that into my K196. You see here it's actually telling me what configuration file I've loaded, and now I need to do certain tweaks to the signal, to the software. I do here 4.2 gigahertz frequency. The sampling frequency is a little bit different. It's 25.6 megahertz. And then of course I also can change the capturing time if I want to, for instance 10 milliseconds, which will save some time for this demonstration. So that's basically it. So let's give it a run. Hit run signal here. You see capturing the IQ data from the FSW, and voila, here we go. We captured and analyzed a UFMC signal. So in the top you see basically the capture buffer. I can simply change that here, for instance, if I want to take a look at the power spectrum. So you see here the skirt type of spectrum view. These little bubbles that you see here basically is the configuration of subbands that is default on the signal generator. I would be able to change that if I want to. And then at the bottom here you basically see a constellation diagram. I also could basically take a full screen view here. So you see we had QPSK, which is actually the modulation scheme that we used. And an interesting piece here is, of course, what's the signal quality now? And if I change here the graph into the list mode, then we get all these type of information, including the crest factor that you can see here. Since UFMC is still an OFDM-based multi-carrier type signal, a very high crest factor of about 11 dB, which is similar to an LTE downlink signal as an example. So it's not overcoming all of the disadvantages that an LTE signal has, which would be also a high crest factor, but it's better in spectrum agility, for example here. So coming back to the software, let's take a look at signal quality. You see here we measure right now an EVM of minus 43.89 dB, which is underneath, significantly underneath 1%. So if you're now designing a power amplifier that is targeting these newly allocated frequencies for IMT Advanced, for instance the 4.2 gigahertz that I used here in the example, then you can of course see what the nonlinearities of that power amplifier do to an UFMC signal using Rohde & Schwarz analysis tools. Thank you for watching.